Good morning, class. Now let's zoom revise the sources of sound. Okay, now let's look at the sources of sound that we're going to discuss in this zoom revise is going to be vibrating string and vibrating air column. Sound is produced by vibrating strings in pianos and guitar. So let's look at the first one, which is a stretch string. Now we have a string which is actually tied to two ends here, and the string is length is L. Okay. Now the first frequency, which we call it as a fundamental mode, okay, is the basic. Now the point where the string is plunged has the maximum displacement and is called as anti-knot. Okay. So this is the point. This is called as what? This is called as anti-knot. The string is said to vibrate in a fundamental mode. Okay, so there is a first frequency. So here, if you realize that, okay, one knot to another knot is half lambda. So this end here will form is a knot. This is a knot here. This is also another knot. So one knot to another knot is half lambda. Okay, so lambda is equals to what? Is equals to 2L. Okay, all right, this is L. So L equals to half lambda. Okay, then we know the formula for frequency. V equals to F lambda. Okay, and then lambda is 2L. Okay, substitute and then we get the fundamental frequency, which is V over 2L. Okay, V will be the speed of the sound. Then after that, from fundamental mode to the first overtone, we plus another half lambda. Okay, we plus another what? Half lambda, not L, half lambda, sorry. We plus another half lambda. So that means we plus here from half lambda, we add another half lambda. We get L equals to lambda. So this is not, this is not, this is anti-knot, this is not, anti-knot, this is not. Okay, all right. So then again, the same way we know the formula V equals to F lambda. Then we substitute this one inside here, then we get the frequency, which is V over L, which is the length. Then we compare this, the first overtone, with this. Overtone means over the tone. That means it's over the first fundamental mode. Okay, the first on top of the fundamental mode. That's how we imagine. Okay, so then we will realize that we compare between this one and this one. We realize that F1 is 2 times the fundamental frequency. So that means this is called as, because here is 2, we call it as second harmonic. Okay, then we move on to the second overtone. That means the second, that means 2 times the fundamental mode. Okay, now that's why it calls second over the tone. That means the fundamental mode. So from here to here, you plus another half lambda. Okay, all right. Now here, what happens is the length is, this is not, this is not, this is anti-knot, not, not. Okay, so you plus another half lambda, you get the length equals to 3 over 2 lambda. So you get your lambda is 2L over 3. Same way, you find V equals to F lambda. So you get your frequency 3V over 2L. Then you compare this with the basic frequency. Okay, so you get F2 equals to 3F0. That means 3 times the fundamental frequency. So this is called, because here is 3, it's called as third harmonic. Okay, all right. So let's look at this other extra information. Plucking at different point along the stretch string, other modes of vibration obtained. Okay, first overtone, second overtone, that's what they're trying to say. Now, one note to another note is half lambda. One knot to another anti-knot is quarter lambda. That means from here, you see here, which I'm going to show here. Hold on. From here to here is 1 lambda. Okay, one wavelength. So this one knot to another knot is half lambda. So 1 naught to another anti-naught is quarter. That means 1 over 4 lambda. Okay. Okay, now let's look on to the next one where the frequency of different modes of vibration of the standing wave along a air column which is open in one end. Either you want to say open in one end or you can also say closed in one end. Whichever lah. Okay, so I have an air column. Okay, so we're going to look at the frequency of different mode of vibration of the standing wave. Okay, so now let's look at this, which is the fundamental mode, is the basic mode. So this one at the end here is not. Okay, this one where it's open in one end, definitely that must be an anti-knot. So 1 knot to 1 anti-knot is quarter lambda. Okay, so this whole length is equals to quarter lambda, then you get lambda equals to 4L. Then go back with the same thing, V equals to F lambda, substitute this one inside here, and then you get the fundamental mode, which is the frequency, which is V over 4L. Then after that, from the fundamental mode to the first overtone, over the tone, okay, the word over, that means is the first time higher than the fundamental mode, okay. So you plus with what? You plus with half lambda. Okay. So you realize that at the end here is not, here is not, and here is anti-knot. Always when it's open is anti-knot. Okay. When it's closed, when it's like this, it's not. Okay. Alright. Then you get your 3 over 4 lambda. Then you solve and then you get your frequency 3V over 4L. Okay. Then you compare your F1 with the basic. Okay, so this is F0. Okay, so this is F1. So you compare F1, you compare with F0, you will realize that F1 is equals to 3F0, 3 times the fundamental mode frequency. So this 3 is called as third harmonic. Okay, then the second overtone means the second time, the second increment to fundamental mode. Okay, that means the first increment, the second increment. Okay, first increment, second increment. So we call it second overtone. So here we again plus with half lambda. Okay, from here to here, from the first overtone to second overtone, we plus half lambda. But if we look at the second overtone, we notice that from the fundamental mode, first time we plus with half lambda, then we plus another half lambda. So it's like you plus 2 second. Okay, all right. So here we get 5 over 4 lambda, and then as usual you put inside the basic formula, and then you get your F2 equals to 5V over 4L. Then you compare this with fundamental frequency. Then you get F2 equals to 5F0. F2 equals to what? 5F0. So 5F0 means is the fifth harmonic. Is the what? Is the fifth harmonic. So that means that in an air column open in one end or closed in one end, there are odd harmonics. Okay, so the next one definitely will be seventh harmonic. Okay, so 3, 5. So they are called as odd harmonic. Okay. So you see here the word here says the open end is a displacement anti-knot. That means the closed end is an knot. Okay, now let's look at the next one, frequency of a different mode of vibration of the standing wave along a air column open in both ends. That means open in both ends. Okay, definitely if it's open in both ends, so this place here must be an anti-knot, this place here must be an anti-knot. Okay, something you have to know. Okay, the fundamental mode, that means the basic mode. Okay, so here is an anti-knot, here is an anti-knot. So from one anti-knot to another anti-knot, that means it must be half lambda. So L is equals to what? Half lambda. So you get L equals to half lambda. Then lambda is 2L. Then you use the same thing. You substitute inside here. Then you get the frequency. Fundamental frequency is V over 2L. Okay, then from the fundamental mode to the first overtone, you plus another half lambda. Okay, you plus another half lambda. So you get this. Okay, then you substitute, you get your formula for the frequency of the first overtone, which when you compare this with f naught, okay, v over lambda 1, so v over lambda 1, okay, this one must be lambda 1 is L, yeah, so okay, there's a mistake here, f1 equals to v over L, okay, so when you compare this, then you will realize that f1 is 2f0, correct? F1 is V over L, F0 is V over 2L. So F0 equals to F1 divided by 2. So F1 is 2F0. Okay. Alright. Then that is the first overtone. So this is called as second harmonic because of the 2 here. Okay. Then after that, for the second overtone, that means second right. That means you plus half lambda for the first. Then you plus another half lambda. The second right, so it's second overtone. So from here to here you plus another half lambda, okay, then here is definitely anti-naught. You have to memorize the shape of the wave in the air column. They are quite famous in the exam also. Okay, then you get your answer. Okay, then you solve like this, you get the frequency of the second overtone, which is 3f2, which is 3v over 2l. Okay, then we know that we compare with f0, f2, 3v over L. We know v over 2L is fundamental frequency. So 3f0. So that means it's third harmonic. So the first one was second harmonic. Okay, second harmonic. The third one is third harmonic. So we call them as even harmonics. Okay, and if you see, they are similar as strings. The vibration of the modes on a string, they are the similar one. Okay, all right. Okay, and correction. Now you see class, I took this notes from the book. Okay, so this is an air column. What is this? This is an air column, open or close in one end. Okay, open at one end here. Okay, now you see this is the end of the open end. Open end. Okay, so from here to here is L. Okay, the length. But the anti-knot is formed somewhere which is not at the open end. It is formed somewhere which is further somewhere here. Okay, so the distance between this one and this one is called as end correction. Okay, so what you must do is, when you know there is an end correction, so we know basic is like this. We know it's open at one end. Okay, so I'm going to write down here. Okay, we know that L plus C is equals to quarter lambda. So lambda equals to 4L plus C. So you just have to plus C. Like for example, if it is like open at both ends and then the anti-knot formed is like that. Okay, say for example, the anti-knot form is something like that. That means there's 2C here, 1C, and then there's 2C here. So your answer will be plus 2C. Okay, like this. L, okay, this one is L, yeah? This one is L. L plus 2C equals to half lambda. So lambda equals to 2L plus 2C. Something like that. So 2L plus 4C. Okay, so that's how end correction is added into the sources of sound. Okay, now here STPM 2017. Okay, after knowing all this concept, let's do the application now. An elastic string is stretched between two fixed points. So we have two fixed points, which we know fixed means a knot and a knot, which are separated at 2.6 meter apart. So this is 2.6 meter apart. If the mass of the string is 0.15 kg and the tension in the spring is 30 Newton, the fundamental frequency of vibration that can be produced by the string. So we can illustrate the whole entire question and we can imagine is something like this. Okay, so they ask us for fundamental frequency. The first keyword is a string. Okay, so we take L equals to half lambda, and then what is L? L is 2.6, and then we use V equals to F lambda. We substitute inside. Okay, now in order to find the V, remember, so the speed of the sound of transverse, speed of the transverse wave, okay, the speed of the transverse wave in the stretch string, okay, will be such as this. Okay, so this is T is for what? T is for tension. Mu is what? Mu is mass per unit length. Okay, so then we substitute the value and we get the answer. Okay, now let's look at this question again. A guitar string, okay, a guitar string has a length L and a mass M. If the frequency of the first overtone of the string is F, okay, what is the tension in the string? Now this is first is the concept of string. So the first overtone, so the basic fundamental mode is half lambda. Then to go to the first overtone will be lambda, correct or not? Because it plus another half lambda. So L equals to lambda, V equals to F lambda, and then you substitute inside here, you get F equals to V over L. Now in order to find V, which is the speed of the transverse wave in the string, okay, we know V is square root of T over mu. T is for tension. You see the questions are kind of repetitive in the STPM for this formula. This formula is very important. Then mu is a mass per unit length. Okay, so which here I will put capital M over L because it's given here already. Then I substitute inside here and then I just play with my maths and I get my answer for the tension, which is MLF squared. So the answer would be A. Okay, now let's look at the year STPM 2016. A long tube which has a tap fitted to it and filled water is shown in the diagram below. A tuning fork of frequency 512 Hz. Okay, this one is sounded above the tube as the water flows out slowly through the tap. So this one is showing us the concept which is similar to the concept of resonance, where it is used to determine the speed of sound in air. Now, the resonance will occur and the frequency of the sound emitted, okay, equal to the frequency of the tuning fork. Okay, so the reason the length of the air column is changed is to hear the frequency of the sound emitted, and the frequency of the sound emitted will equal to the frequency of the tuning fork, which is 512 Hz. The first question, the first loud sound is heard. That means it's a fundamental mode. Okay, fundamental mode. When the length of the air column is 15.7 cm, so I'm going to just put here L1. As the water continues to flow out, a second loud sound is heard. That means this one must be the first overtone. When the length of the air column is 48.1 cm, so this is L2. Catch the stationary wave in the tube when the loud sound are heard. Okay, so this is the tube. Okay, so the first one is fundamental mode. Now remember this first thing, this is an open in one end or close in one end, or we say open in one end, air column, whichever lah. Okay, so here is not, this is water, this is not, and this one is anti-knot. So the length of the air column 15.7. Then to the next one, the second loud sound you plus with half lambda. So this one will be 3 over 4 lambda equals to this. Okay, but then remember this one got n correction. Okay, all right. What is meant by n correction? Now n, okay, now it's like this. Okay, this is not, this is anti-knot. Sometimes this anti-knot is formed somewhere which is not near at the end correction, which is not near at the open end. So this is the open end. This is where the anti-knot is formed. So from here to here is C, from here to here is the length. So what is C? C is the distance between the anti-knot and the open end is called as end correction. By right, the anti-knot is supposed to be formed here, but then it is formed somewhere which is very far from the open end here. Okay? Alright. Now, determine the velocity of sound. So at the first resonance, which I took, this one I took example from the past year's book, yeah, their solution. So this is fundamental mode. Okay, so fundamental mode here, you see here is quarter lambda. So quarter lambda is equals to L plus C. Okay, L plus C. Okay, write down here. L plus C is quarter lambda. Okay, for the second one, it will be, because this one is L1, for the second loud sound, L2 plus C equals to 3 over 4 lambda. Because from here to here, you plus half lambda. And then you solve your maths like class. Solve everything, you get your answer for your lambda. Now, V equals to F lambda. Now, why they use F as 512? Because of resonance. Because it says the frequency of the sound emitted equal the frequency of the tuning fork. So that's why they use 512, which is the frequency of the tuning fork. Okay, so then they substitute and then they get, they get the V. So this is the answer of the V. Then they substitute in one of this equation, they get the answer for the end correction.